we need to go down the cart 10 centimeters.
Go down the track.
Go down the track. Thank you. Alright. 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 So question 5 is asking us, note the shape of the force versus time and the acceleration versus time graph. How are they similar and how are they different?
They have the same like pattern. It looks like they're
I'm looking for a very
similar,
specific
but they're out of sync. Like
what?
I don't know. It looks strange.
Like the acceleration kind of like no.
This one's also a lot smaller of a range.
It's a smaller of a range, while the acceleration is a wider of a range.
This one also has a larger slope,
Yeah. Corbin,
which is interesting.
you want to put in your input?
It's the same as what you guys
All right.
Also, here we can see the relationship between them. So I assume this is just as it goes.
Click examine and move the mouse across the force versus time graph. So we need to do this one. So the force maximum is about 2.6. Yeah,
I'd say
about
that. I think that one's higher.
This one?
Yeah.
So about 2.98. Well,
That one, I don't think you can measure it. Oh, click this and then you.
Yeah.
There you go.
Well, the maximum here is about 8, 9, 10. So we see the differences in about like the max here is going to be a lot higher
Yeah.
than there, and the minimum is about 13 there, while it's -5.
Well, it's also different forms of measurement. This one is the change in meters per second, and then that one is the force applied.
Yeah. The graph of force versus acceleration should appear to be a straight line. To fit a straight line to the data, click the graph, then click linear fit, record the equation registered on the line table.
I think that's this.
Yeah, it's for this one.
Yeah.
I believe it's this one, yeah. So,
I'm in the water. Oh.
Oh, click the graph first. Actually.
there it is. It's the same thing anyway. Oh, oopsies.
Couple.
So, it fits pretty well. We kind of see that linear here.
So that's the slope of the three.
Yeah. Alright. Add extra massive cart if you're using a green metal cart. Remove the accelerometer. Alright, so we want to add those to the cart.
So as acceleration rises, the force rises as well.
Yeah.
So more mass provides a higher acceleration. Maybe?
It will also cause the force to be higher as well.
Which means either this is going to be a slope like that or it will be higher up.
Yeah. I would say it will be higher up since we're going to have more force to it. And the acceleration and the force will be a lot more similar this time.
Closer to 1-to-1.
All right. In the same 10 centimeter range.
yeah, it's definitely increased the rate.
Yeah.
of-
I would say these ones look a lot thinner, like going up and coming down. They're a lot closer than they were before. And then we see the force a lot higher than it was before as well. Is it this one? Yeah, I think it's this one. No, it's not that one. Oh, yeah, it is. Oh. Alright. So, yeah, we see our maximums and minimums a lot higher, and a lot lower. So there we kind of have -8.
Apart from that one.
Yeah.
But overall, they've increased a lot.
Yeah. And we might see kind of similar, yeah. And we've seen this increase a
Very
little bit as
slightly.
well. Very slightly, but it's still around the same. And then we see here kind of, it's a lot closer to up here than it was before as
It's
well.
become more steep.
Yeah.
And I think that's good.